So, can the invisible power of the wind solve one of Pakistan's most visible, most urgent problems? The country is facing a massive energy crisis, and for years, a lot of people have been looking to the skies for an answer. In this explainer, we're going to dive deep into the data from a huge scientific study that literally mapped out Pakistan's wind potential to find out where that answer might be blowing.
Okay, so before we can even talk about a solution, you got to understand the scale of the problem. Pakistan is facing what the research paper itself calls an acute energy crisis. And look, this isn't just some minor inconvenience. It's a massive challenge to the economy and to the daily lives of millions of people. And here's the number that really puts it in perspective. On any given day, the country is short by as much as 5,500 megawatts of electricity. That is a huge gap between the power people need and the power they actually have, and it leads to constant blackouts and really holds back progress.
And this reality right here is exactly why this research got started in the first place. The authors put it pretty bluntly. This massive gap, plus the rising cost of fossil fuels, means that finding an alternative like wind power isn't just a good idea, it's urgent. So the scientists went on a hunt.
And this wasn't just some casual look-see. We're talking about a systematic, nationwide hunt. Researchers were on a mission to scientifically measure and figure out where exactly in Pakistan the wind has enough juice to be a real solution.
All right, so take a look at this map. The study zeroed in on 7 different spots, stretching all the way from the capital, Islamabad, up north, right down to the coastal areas of Jimpir and Khadi Bandar in the south. This gave them a fantastic snapshot of the entire country's landscape.
Now, to do this right, they needed a ton of data, and they didn't mess around. They analyzed a massive data set that spanned 12 full years. I mean, you have to do that, right? It's the only way to get a true picture and iron out any weird, short-term weather flukes.
Okay, so after crunching all those numbers from all those years, there's one obvious question. Where did they find the good stuff? Where was the wind really blowing? Well, the results were surprisingly clear-cut. In fact, you can really understand the main findings as a tale of 2 completely different cities. It's the perfect way to see the dramatic contrast between the country's north and south.
And the difference between the two is just wild. Down on the southern coast, you've got Khadi Bandar, clocking in as the champion with an average wind speed of just over 4 meters per second. Now compare that to the capital, Islamabad, way inland, with a tiny average of just 1.33. That's a 3-fold difference.
This chart just lays it all out, doesn't it? I mean, look at that. Khadi Bandar is the undisputed winner. The other coastal spot, Jimpir, is in a solid second place. And then, way down at the bottom is Islamabad. It's kind of simple, right? Geography is destiny here. The coast gets the wind. But the story's not over yet. Because, and this is super important, just measuring how fast the wind is blowing, well, that's not the whole story. Not even close. If you want to know if you can actually make electricity, you've got to look at something way more important, the wind's actual usable energy.
So you might be thinking, okay, faster wind, more power, duh. But is it really that simple? Turns out it's a bit more complicated, and this is where the real science of wind energy gets fun.
Scientists have this term called wind power density, and here's the best way to think about it. Wind speed is like how fast a boxer's jab is, but power density? That's the knockout punch. It's not just about speed, it's also about the weight or density of the air behind it. It's the actual oomph that can turn those heavy turbine blades.
And when you look at it this way, through power density, that gap between our 2 cities becomes a canyon. Get this. At its peak, Khadi Bandar had a power density of almost 259 watts per square meter. Islamabad, at its lowest, a measly 1.68. So we're not talking 3 times the difference anymore. We are talking over 150 times more power potential on the coast. That's just incredible.
Okay, but there's one last piece to this puzzle, and it's something every wind engineer knows is absolutely critical. You have to go up. The height of the turbine makes a world of difference.
And it makes perfect sense, right? Down near the ground, you have trees, buildings, hills, all that stuff creates friction and slows the wind down. But when you build these turbines super tall, up to 100 meters, you get above all that clutter. Up there, the wind is faster, smoother, and way more powerful. So yeah, the higher you go, the more juice you can generate. A lot more.
So let's put all these pieces together. The location, the speed, that power density thing, and the height. What's the final verdict from the scientists? What's the real potential for wind power in Pakistan? Well, according to the official international standards, wind sites get classified based on their power. And here's the big surprise. Even the best location, Kati Bandar, only qualifies as marginal for big utility-scale projects. And the other sites, including the second best one, they're all officially classified as poor.
Now I know what you're thinking. Marginal? Poor? That sounds pretty disappointing. Does this mean wind power is a dead end for Pakistan? Not at all. It just means you have to reframe the solution.
So here's what it all boils down to. First, the southern coast is absolutely the sweet spot. That's where the best potential is. Second, most of those other inland places, they're just not right for those giant sprawling wind farms you're picturing. But, and this is the most important part, that doesn't mean they're useless. In fact, they are perfectly viable for a different kind of wind energy.
And that's the big twist. The study's authors conclude that even in those poor areas, the wind power is still substantial enough to be used. The key is just using the right tool for the job. You got to be smart about it. And in this case, that means using small-scale wind turbines that are designed for exactly these kinds of conditions.
And that leaves us with a really fascinating final question, doesn't it? Maybe the solution to Pakistan's energy crisis isn't a few massive wind farms on the coast. What if instead, it's a huge network of thousands of smaller turbines spinning away in villages and towns all across the country? The answer, it seems, is definitely blowing in the wind. It just depends on how you choose to catch it.